Hi there, we're going to pick up where we left off with chapter 11 now. So I already have question 21 written up on the whiteboard. And my instructions say solve by the square root method. So on the final exam, we know 4 ways to solve a quadratic. We know that we can factor, we can use the square root method, we can complete the square, or we can use quadratic formula. On the chapter 11 test, I'm actually going to look at your work so that you use the method that it says to use in the problem. However, on the final exam, whatever goes. So if some things can't be factored, but if you want to try to factor them because that's always been easiest for you, great. Quadratic formula works for all quadratics, every single one of them. So if this is the method you prefer, that's great. I won't know any better because it's multiple choice. But on this test, I'm looking to make sure that you know all of those methods. So first step, let's get the squared part alone or isolated, which this problem already has done for us. And so again, radicals, square rooting, and squaring are inverses, meaning that they undo each other. So we can just cancel that out, and then that 2x minus 3 breaks free. On this side here, while in chapter 10 we only looked at the positive square root, in chapter 11 we reverse that and we consider both the positive and the negative answer. So if we have a squared, we should anticipate 2 answers. Sometimes the same answer comes up twice, but that won't happen here. So instead of writing positive 18 and then negative 18 separately, just like it said in the notes, we have this little symbol that stands for both, plus or minus the square root of 18. All right, we do need to check to make sure that that could be simplified if possible. You can solve for x first, or you can simplify right here. It doesn't really matter. I'm going to add the 3 to both sides. So I get 2x equals 3 plus or minus the square root of 18. And then I'm going to divide by 2. I have to divide the whole thing by 2, so make sure your fraction bar goes all the way across there. And then x equals 3 plus or minus radical 18 over 2. And so over here I'm going to simplify that 18. So 18 is 2 times 9. 9 is 3 and 3, so we have that pair. 1 cancels, that 3 breaks out, and that 2 stays under the radical. So I'm going to rewrite this, and my final answer is x equals 3 plus or minus 3 radical 2 all over 2. If these were even, there would be more we could do, but in this case, nothing can be reduced. That's your final answer. All right, don't accidentally cross those off. That guy is protected by the radical, so this is as far as you can go. All right. Question 22 talks about completing the square, which has its own kind of crazy set of rules. X squared plus 4x. I'm going to leave a little space right here, equals 2. Remember, if you go back to the video, I wrote out the notes. We need to make sure a is equal to 1. It will be on the test because I want to give you kind of the least complicated one. And then we need to move the c. And c is already moved. It's already on the right side. We're going to set up those blanks. We're going to take half the b. We're going to square it. And then we're going to add that number to both sides. So that's the step I'm on next. So 4 divided by 2 is 2. Squared brings us back to 4. So if you put in little blank spaces right there just to help you remember, this is the number you're going to add to both sides. So plus 4 plus 4. This this now can be factored. The whole reason it's called complete the square is that it makes a perfect square. So two numbers that multiply to 4 that add to 4 are x plus 2 times another x plus 2, or just x plus 2 squared. And on this side here, 2 plus 4 is 6. So that brings us all the way through there, and then we're at the we factored it, so that would have been our next step. And now we're going to go back to the square root method. So you see you have that squared term on the left. My next step is going to be to square root both sides. So that's going to cancel that out. So we end up with x plus 2 equals, don't forget the plus or minus. And 6 can't be simplified, and there's no number in front of the x, so we're just one step away from being done. Try to remember to write the constant first, so go ahead and put that -2 first, and then the radical in the back, plus or minus the square root of 6. And that's our final answer there. Okay, number 23 says solve using quadratic formula, and I did give you kind of some big numbers there. Let's see what happens. When you use quadratic formula, if you want to pause right here and have that formula right next to you, while I think I mentioned that a few problems ago at the beginning maybe, because I'm not going to use my board space to write out the formula. Don't take the x's. You just are looking at the coefficients in front of the x. So the formula says -b, which means do the opposite of whatever the b started off to be. So b is -8, so when I reverse that, it's a +8 plus or minus the square root of b squared. Whether this number is negative or positive, when you square it, it always is going to turn out to be a positive. Minus 4 times a times c, bring that negative with you there, all over 2 times a. And now we just need to keep simplifying until we can't simplify anymore. So 8 plus or minus the square root of 64. Two negatives make a positive. 4 times 4 is 16. 16 times 9 is 144. I always come over here without the use of a calculator, so good thing I could pull that one out there. All over 8. 64 plus 144 is 208. So 8 plus or minus the square root of 208 over 8. I'm sure that 208 can be simplified. So 208 is 2 times 104, which is 2 times 52, which is 2 times 26, which is 2 times 13. So we're taking square roots. So make sure that you circle your pairs. I have a pair of 2's, one guy cancels. I have another pair of 2's, one guy cancels. So that breaks out, that breaks out. This is still under the radical. Oops, excuse me. All right, so I'm going to rewrite. 2 times 2 is 4. So I have this 8 plus or minus 4 radical 13 over 8. Okay, we have a few options. I'm going to erase this because I have to keep simplifying. And this is kind of a trickier example, but I'm sure you can get through it. All right, so we either need to split this into two separate fractions. So we would do 8 over 8 plus or minus 4 radical 13 over 8. And then we could reduce each piece. So this would be 1 plus radical 13 over 2. That's a perfectly acceptable answer. Or you need to take the entire numerator and think, is there a GCF there that would cancel out with that 8? So both of these numbers have 4 as a factor. So I'm going to pull that 4 out. And that's going to leave me 2 plus or minus radical 13 over 8. And that 4 now reduces with that 8, leaving 2. And so this is an also alternate. I'm sure your book chooses one way or the other. Both are correct as long as there's not an imaginary number, an I involved. If there's an I, you have to split it. If there's not an I, both of these work. Just don't stop with this answer. Keep reducing all the way until you can't reduce anymore. All right. 24 is actually from one of our last sections in chapter 11. Again, remember I said I couldn't fiddle with the order of things, so I couldn't like try to put this at the end or anything like that. So this is the one word problem we're doing. And so it says v of x is equal to x squared minus 14x plus 28. Oh, and then I have an equals 0 there. Oops. Just kind of scribble that out, if you will. So sorry. Okay, now we're looking for the minimum value. Think about, I'm going to get into the graphing ones, but the number in front here is a positive 1. So we know it's going to open up. So we know the vertex, that's the thing we're searching for, is going to be a minimum value. So we're looking for that minimum value. There is a shortcut that x is equal to negative b over 2a. This is what you're going to need to be successful on this specific problem, is this shortcut. So again, you might want to have that step and then maybe these shortcuts, the steps for completing the square, the quadratic formula, and this as the shortcut for the word problem. So again, we start with a negative. So since I have a negative 14, I'm going to change that to a positive over 2 times a is 1. So my x value is 7. And in order to find the y, or in this case the v, which is the value of the stock, I'm going to plug that 7 in. So 7 squared minus 14 times 7 plus 28. So 49 minus 98 plus 28 is negative 49 plus 28. Oh, that's a problem. Because the value of the share of stock cannot be negative. Okay, so bear with me here. Kind of working off the cuff. Go back in there and let's just change. No, that's not going to do it. How can I just real quickly, well, on the test, I'll go back and make sure. So this is the process. I apologize for the goof. We're going to get negative 21. Technically, you cannot have a share of stock that's a negative value. I thought I got this one right out of the book, but I guess I didn't. So this is the process. The one on the test will work out fine. So trust me there. And then it says X is the number of years after January 2007. So if I'm adding 7 to the year 2000, what year is it? It's 2007, and the value of the stock is negative $21. So that would be the answer to the question. Again, my apologies. All right, 25 says complete the square to put in vertex form. So the complete the square process for this is super similar but not exact to the complete the square to solve. It has some similarities. There's a few pieces that are just a little different. Remember, we want to put it in vertex form, which looks like this. So this is always the opposite when we go to graph it, and then this value here stays the same because it does ask us for the vertex when we're all done. And this tells us how wide or narrow or whether it goes up or down. And all of these notes can be found in section 11.6 if you need to go back and review. All right, but the complete the square piece is in 11.7. So let's pull that 2 out. Now we're only going to pull the 2 out of those first few terms. This c we're going to pull to the back a little bit. So this is going to be x squared plus 2 goes into 12 6 times. I'm going to put a space right here. I'm going to add the 5 and then put a space here. And please note, after I multiply through by that 2, these numbers need to be opposites. Okay, so this is what I'm going to use to complete the square. So 6 divided by 2 is 3. 3 squared is 9. So I'm going to put a plus 9 right here. But what did I really multiply by or add? 2 times 9 really represents the number 18. And so what I'm going to put in the back here is a minus 18 because my equal sign is here. So if I add something to the right, I also need to subtract it so that my scale is balanced, so to speak. You want your equation to be balanced. All right, I am going to rewrite this in this form. Again, 2 numbers that multiply to 9 that add up to 6 are going to be 3 and 3. You can also find that right here. That number there, after you take half, but before you square it, this will always, 100% of the time, be the number that goes inside the parenthesis. And if this is positive, this will be positive. If this is negative, that will be negative. All right, so I'm going to erase a little bit here. So that 2 comes straight down. This is going to be x plus 3 squared. A positive 5 and a negative 18 make negative 13. So if you recall the equation I had right here and I mentioned opposite same, it says state the vertex. So the vertex of this parabola would be at negative 3, do the opposite, and then the back number, the sign stays the same. Will this point be a max or a min? This is a positive 2, and so it's going to be like this. So that number there is going to be a minimum value, and so I just need you to write minimum, and that takes care of that. All right. 26, now it's looking like we're going to graph. Okay, if I tried to put graphs in the test itself for anybody that was printing, if they don't I hope they transfer. I had a little trouble with that. I don't think I knew how to do that when I made the review, and then I messed around a little bit more. You can always home make your graph or print out some graph paper from online. And then that's a negative 4. Okay, so 3 things real quick. It says vertex. So my vertex opposite, same. So my vertex is going to be at negative 2, negative 4. State the axis of symmetry. Remember that vertical line that splits it so that it's symmetrical on both sides. Whatever that number is, your axis of symmetry is a vertical line. Vertical lines have the equation x equals, so x equals negative 2. And then it says to graph. So 2, 1, 2, 3, 4. It's going down because that's negative. That axis of symmetry is not actually a part of your graph. You're just kind of using that to guide you. So negative 2, negative 4 is going to be here. And then I need to find a second point so I get a sense of how wide or narrow it might be. X equals 0 is always a good choice. Let's see what happens. And so if I plug in 0 there, I get 0 plus 2 is 2, squared is 4, but there's that negative out in front, so it's a negative 4. Take away 4 more is a negative 8. So if x is 0, the y value is negative 8. So I'm going to just come over here. So negative 8 is right there. seems to me that this is 2 spaces. Between -2 and 0 is 2 spaces. So there has to be a match on the other side. So there has to be a match right there. Once you have 3, don't just turn in your test with just that. Keep in mind that it goes forever. So make sure you kind of extend it, especially if you just plugged in -1 and you just have like a little tiny hook right here. It's an entire curve and then with arrows indicating that you know it goes on and on and on. Okay, 27, similar, not exact. It's already in vertex form. Notice that one piece of it is missing. And so for that piece, you need to add in a 0. So it's 1/2. We should expect that to be a little bit wider because it's a fraction between 0 and 1. X minus 3 squared. And then there's nothing back here. So if this helps you indicate that you know that that's nothing, because then the vertex is going to lie right there on one of those axes. All right, so find the vertex. It goes opposite, same. So the opposite of -3 is 3, and then that 0 is the y coordinate. And so I can go straight to the graph. 1, 2, 3, 0. So there's my vertex. It doesn't ask you to state the axis of symmetry, but there it is, because you kind of need that to graph. Now, let's see what, and then we're going to work on, oh, that's not very straight. We're going to work on finding a second point. Now, if I plug in 0, watch what happens. So I would have 1/2 0 minus 3 squared plus 0. So this is going to be a -3 squared, which is 9. So now I have 1/2 of 9, which gives me 4.5. And you can definitely use 4.5 if you want. For some of you, though, that's going to seem really gross because you're like, I don't want to graph a fraction. And so what other number might we substitute? Let's try x equals 1 or even x equals -1, your choice there. So what happens if I plug in 1? I get 1/2, 1 minus 3 squared plus 0. So I get 1/2. 1 minus 3 is -2 squared. Remember to square before you take half. So -2 squared is 4. 1/2 of +4 is 2. And then since we're adding 0, then my y value is just 2. So 1, 2 is on my graph. So write 1 up 2. Much better than graphing a fraction. Looks like I'm to the left 2 of my axis of symmetry. So I'm going to go to my right 2. This is exactly the type of thing I'm talking about when I say don't just like give me a little tiny horseshoe. Okay, even if your graphing skills aren't the greatest. All right, give me a larger curve. You know it's getting wider as the numbers go out on either side of that vertex, and then the arrows to complete. All right, I think that's all the graphing. We'll see. I don't quite remember. I can't see the whole thing at once. So 28. 28, I give you the answers, you come up with the quadratic. I think on the test, I might have given you a fractional one. So you might want to go back and review the fractions. I learned some things between creating this and creating that on how to type some of this stuff in. So the solutions are 2 and -9. I'll do a kind of bonus one here in just a second. So remember to change the signs. And then just multiply it through, just FOIL it out. X squared plus 9x minus 2x minus 18. Gather your like terms, So your equation would be x squared plus 7x minus 18. And that's it. That's all you have to do. Okay, what would you do if it's a fraction? Imagine that slip and slide factoring method that we've been working on since like the second week of school practically. Let's say I gave you the solutions were negative 2/3 and positive 1/6. Okay, so you're still going to change the signs, but this denominator is going to slide in front of the x. So this is going to be 3x plus 2. Change the sign, and that 6 is going to slide in front of the x, 6x minus 1. And that's all you do, and then you FOIL it in the same kind of thing. All right. Solve by any method. So you may look at x squared plus 4x minus 12 equals 0. I mentioned this at the beginning of this video. You can factor it, you can complete the square, or you can use quadratic formula. It's a little bit your choice. I do notice this factors. That's easy for me, easiest for me. It might not hold true for you. Two numbers that multiply to 12 that add up to positive 4 are going to be x plus 6 and x minus 2. Which simply makes my answers negative 6 and positive 2. And whatever method you use, when you continue to simplify that all the way through, those are going to be your answers as well. Is that it? That is it. We are at the end. Oh, that's so fabulous. So good luck. If you have specific questions, please reach out to me like always. You guys are doing a great job communicating, most of you. Sorry about the one that didn't work out. If you need me to make up another example, I'm happy to do that. There's also some in your book that you can kind of look at with the shortcut negative b over 2a. Hope you all are doing well. Have a great day. And my next video will be going over the final exam review sometime soon. Thanks. Take care. Bye-bye.